Everyone thinks the Space Shuttle Columbia was just another launch. They didn't know it was already doomed. On January 16, 2003, at 10:39 in the morning, Space Shuttle Columbia lifted off from Kennedy Space Center. 73 seconds into ascent, traveling at 900 miles per hour through the skies above Florida, something catastrophic occurred. A piece of foam insulation roughly the size of a briefcase detached from the external tank. No one on the ground saw it happen. The astronauts felt nothing. And for the next 16 days, as Columbia orbited Earth, completing its 16th and final mission, Mission Control had no idea what was coming. But Columbia's story doesn't begin on that January morning. It begins much earlier, with ambition, discovery, and a mission that would reshape our understanding of how life persists in extreme environments. The crew of 7 had trained for years. Commander Rick Husband, pilot Willie McCool, and mission specialists Michael Anderson, Ilan Ramon, Kalpana Chawla, David Brown, and Laurel Clark were among the finest pilots and scientists NASA had ever assembled. Their 16-day mission was called SDS-107. It wasn't a trip to the International Space Station. It wasn't a deployment mission. It was pure science, the kind of work that rarely makes headlines but quietly advances human knowledge. Columbia carried 80 experiments in 2 pressurized modules. They studied combustion, materials science, Earth observation, and biology. One experiment in particular would have changed everything we knew about life's resilience. The crew conducted research on nematodes, microscopic roundworms, to understand how living organisms respond to microgravity. They examined how flames burn differently in space. They grew protein crystals that could lead to new medicines. These weren't glamorous experiments. They won't be remembered in popular culture. But they were the unglamorous backbone of why humans venture into space at all. For 16 days, the crew worked. They slept in shifts. They photographed Earth below. They made observations that would have taken decades to replicate on the ground. And throughout those 16 days, the foam strike from launch continued its silent work. The impact had created a hole in Columbia's left wing, a breach roughly the size of a silver dollar, hidden from every camera, every sensor, every eye. On February 1, 2003, at 8:44 in the morning, Columbia began its descent. The shuttle was traveling at 12,500 miles per hour, re-entering Earth's atmosphere at an angle precisely calculated to slow it without burning up. The crew had completed their work. They were going home. Everyone believed the mission had been nominal, a complete success. Mission Control had run thousands of simulations. Nothing suggested danger. At 8:54 a.m., sensors began to register unusual readings on the left side of the shuttle. Temperatures were climbing higher than expected. Hydraulic systems were failing. The first indication appeared as a single data point, a blip that could have been instrument noise, then another, then more. Within minutes, the pattern became unmistakable. Something was catastrophically wrong. At 8:59 a.m., Columbia's last transmission came through. Pilot Willie McCool radioed, "Roger, Houston, we've had a problem here." Those words would echo through history. The foam strike, invisible and undetected, had done its work. The breach in the wing was allowing superheated gases to penetrate the structure during re-entry. The shuttle was coming apart from the inside. Seconds later, Columbia broke apart over Texas and Louisiana. The debris field stretched across 2,000 square miles. 84 seconds had elapsed between the first sensor anomaly and structural failure. The crew had no warning. They didn't know the foam had struck. They didn't know about the breach. They were conducting final systems checks when the shuttle came apart around them. But here's what's often lost in the tragedy. The work they were doing mattered. The nematode experiments would later be recovered and analyzed. The combustion data contributed to our understanding of fire behavior in space. The materials science results informed future spacecraft design. Columbia's crew didn't just die in an accident. They died in pursuit of knowledge that would benefit humanity. The investigation that followed was unprecedented. Engineers and investigators examined every fragment, every telemetry record, every decision. They discovered that the foam strike had been noticed by some engineers before launch, but the concern was dismissed. The risk assessment process had failed. The communication between teams had broken down. Columbia's loss became a catalyst for transforming how NASA approached safety. The scientific legacy didn't end with the tragedy. Researchers preserved and studied the experiments that could be recovered. The data from SDS-107 contributed to multiple peer-reviewed publications. The mission's work on combustion informed the design of safer spacecraft. The nematode research advanced our understanding of biological adaptation. Columbia's crew's final mission continued to teach us, even after they were gone. Today, Columbia's name is etched into memorials, but more importantly, it's embedded in the safety protocols that protect every astronaut who launches today. The foam insulation was redesigned. The inspection procedures were revolutionized. The communication culture at NASA was fundamentally altered. 7 people died so that space exploration could become safer, not just for America, but for human spaceflight itself. The untold story of Columbia isn't just about tragedy. It's about what these 7 scientists and pilots accomplished in 16 days. It's about the experiments that continued to yield results long after they were gone. It's It's about how their loss fundamentally changed how we approach the risks of space exploration. Columbia's final mission became, paradoxically, one of the most consequential missions in shuttle history. Subscribe to uncover the stories that reshaped space exploration, the missions, the failures, and the discoveries that changed everything.